In section 7.4, we're going to use the substitution method to solve systems of linear equations. So here's our first example. We're asked to solve the system 2x plus y equals 5 and y equals negative x plus 3. Now, last section we learned that we could graph these and find their intersection point, and that method is good, but it's not always accurate, especially if our answers happen to be a fraction. So outlined on the left side of the screen here are the steps involved in solving a system by substitution. And the first one says isolate one variable in either equation. Well, we can see right here that we have y equals negative x plus 3, and y is already isolated. So what I'm going to do is in this first equation, wherever I have a y, I'm going to substitute in brackets negative x plus 3. So basically I've rewritten equation 1, and in place of y I put negative x plus 3. So now I'm going to solve for x. So 2x, if I distribute, I get negative x plus 3 is equal to 5. 2x subtract 1x is x, plus 3 is equal to 5. And if I subtract 3 to the other side, I get a value that x is equal to 2. So now I need to find the y-coordinate of that point of intersection, so I'm going to substitute back. You can substitute back into either one, but you might as well substitute back into the second equation. So to find y, I have the equation y equals negative x plus 3. So y is going to equal, in place of x, we found that to be negative 2, and negative 2 plus 3 is 1. So therefore, the intersection point is going to be 2 and 1. Again, to verify, if you plug 2, 1 into this equation or this equation, it's going to make those equations true. Okay, here's our next example. Again, we need to isolate one of the variables first. And if you look at our first equation, we could isolate either one. So let's just isolate x by subtracting the y over to the other side. So x is going to equal 8 minus y. So therefore, I have 3 in place of x. I'm putting 8 minus y. Subtract 2y is equal to 14. So basically, wherever I had an x in my second equation, I put 8 minus y. So now my equation is down to one variable, and I can solve. So I'll distribute the 3. So I get 24 minus 5y is equal to 14. If I subtract 14 to the other side, I get negative 10. Dividing both sides by negative 5, and I get y being positive 2. So there's my y coordinate. And now I need to find x. Okay, so to find x, I'm just going to get a new page here. Again, we had x was equal to 8 minus y. So x is equal to 8 minus 2. So x is therefore equal to 6. So my point of intersection is the point 6, 2. Again, if I put 6 in for x and 2 in for y, 6 plus 2 is 8. If I put 6 in for x, 3 times 6 is 18, 2 times 2 is 4, and 18 minus 4 is 14. It works in both, so that is a valid solution. Okay, in this question, again, we're asked to solve the linear system, and again, to isolate, this is probably the easiest to isolate that y right there. So I'm going to subtract the 4x to the other side. So y equals negative 4x plus 5. So wherever I have a y in here, I'm going to put in negative 4x plus 5. So 2x minus 4, negative 4x plus 5 is going to equal 7. So this becomes plus 16x minus 20 is equal to 7. If I add 7 to the other side, I'm going to get 27, and on this side I get 18x. And if I divide both sides by 18, I'm going to get x equals 27 over 18, and 9 goes into 27 3 times, and 9 goes into 8 twice. So I end up getting a fraction for x. No big deal, we treat it the same way. So to find y, we do the same thing we did before. I have y equals negative 4 times 3 over 2 plus 5. So I'm substituting x into this equation up here. And negative 4 times 3 is negative 12 divided by 2 is negative 6 plus 5. So y works out to be negative 1. So the point of intersection is 3 over 2 and -1. In our last example, this example is a little bit more difficult to do as far as substitution goes, but I'll just show you just in case you may want to attempt this strategy another time. There will actually be another method to do this one. So again, this might not be the best way that I show you to solve this system, but it's again a way you could do it. So in this particular case, I've noticed that 3 is goes into 6 twice. So I could isolate 3y by subtracting 18 over and adding the 3y to the other side. And then in my second equation, I'm going to write it as 4x minus 2 times 3y is equal to 18. And now, in place of 3y, because I have 3y here, I'm putting in 5x minus 18. So I'm going to get 4x minus 2 times 5x minus 18 equals 18. Distribute the -2, and I get -10x plus 36 is equal to 18. So this gives me a -6x, and if I subtract 36 to the other side, I'm going to get -6, and divide both sides by -6, and I'm going to get x equaling 1. So now that I've found x, I can go back and find y. So again, I'm going to use this equation up here that says 5x minus 18 is equal to 3y. So 5 times 1 minus 18 is 3y. So 5 minus 18 is -13 is equal to 3y. And if I divide both sides by 3, I get y is -13 over 3. So my solution as a coordinate would be 1, -13 over 3. Now, as I said, there will be probably, there is an easier way to do this question. So this isn't the best strategy for this one, but it could still be done if you had to do this question by substitution. Okay, in our last example, I guess the last one was our second last example, we're given a system that has fractions. So sometimes it's best to get rid of the fractions to make our life a little easier. So if we did that, I could multiply everything by 6 in the first equation and everything by 12. So 6 times a half is going to give me 3x plus 6 times 2/3 is going to give me a 4y. That equals -6. Similarly, 12 times y is going to give me 12y is equal to 3x minus 12 times 5 minus 3 is going to be 60 over 3, which is going to be 20. Now you notice I have a 3x in each equation. And again, there is another method to do this one, but if we're going to do it by substitution, I'm going to take my top equation and I am going to isolate the 3x by itself. So I'm going to get 3x is equal to -6 minus 4y. And then I'm going to replace in here -6 minus 4y. So my second equation now is going to be 12y equals 3 times -6 minus 4y, subtract 20. So this is -18 minus 12y minus 20. So if I add 12y to the other side, I get 24y is going to equal -18 and -20 is -38. And if I divide, I'm going to get -38 over 24, which is going to be -19 over 12. So now I still have to go back and find x. So I'm going to take my equation 3x equals -6 minus 4y. And in place of y, I'm putting -19 over 12. Which this is going to equal -6 minus, so this becomes a plus actually, because 2 negatives. 4 goes into 12 3 times, so this is really going to be 19 over 3. And now there's a couple of ways I could blow everything up by 3 to get rid of my fraction. So I'm going to get 9x is equal to -18 plus 19. So 9x is equal to 1, and therefore x is 1/9. So my solution is going to be 1/9 and -19 over 12. Again, substitution probably isn't the best strategy for this one, but again, the whole idea of this question was showing you that when you get fractions to start with, you can blow up and get rid of your fractions or multiply through by the lowest common denominator to get rid of the fractions, and then you end up with a linear system with no fractions. Okay, there is your assignment for today, and there's also a handout that goes with it, and you'll get that handout in class. So give those a try, and if you have any questions, check the answers on the website.